All right, so I'm gonna check your work, so you fine. Right, Shweta, let's begin, right, Shweta? So
Mm.
in the first question, they want us to find the values of H and K such that H, K, and R, what's saying? H and K are elements of the real number system, right? So they are real numbers, right? And they're saying 3 plus 4i is a root of the quadratic equation. Now, Shweta, if this is the quadratic equation we have, right? And they're saying that H and K are real numbers, then the roots would exist in what pairs?
Conjugate.
So you say that like you're dribbling in your mouth.
I eaten a protein bar, so my mouth full.
Shit, I feel like the next time I see you, you're gonna have big guns, you're gonna have like big muscles.
Hey, yes, sir. I do hammer curls today, and I do hammer curls with 50.
Wait, okay. And she's like a lean beef patty or something on TikTok.
And I never see that one.
Oh, oh. But yeah,
Mm.
like you're gonna have like big guns next time I see you.
Yeah, yeah, I'm gonna bulk up.
Yeah, right? All right, so because the coefficients for x and the constant term are all real, then the root
Mhm.
is conjugate pairs. So in that instance, z1 would be equal to 3 plus 4i, and z2 would be equal to what?
3 minus 4i.
Okay, because in this question we're dealing with x, we should probably say x1 and x2, right? So,
Okay.
yeah, right, x1 and x2. Now, recall, if you want to figure out the equation of a quadratic, you could look at sum and product, right? So
Mm-hmm.
it would be x squared minus the sum of roots by x plus product of roots equal to 0. So I'm just going to write back x squared. All right, I'm going to find the sum of the roots. So that's going to be 3 plus 4i plus 3 minus 4i x and the product of the roots now. So Shweta, if they exist as conjugate pairs and we could use difference of two squares,
Yep.
right? So that's going to be 3 squared minus 4i squared. Yeah,
Yep.
right? Equal to 0. I'm going to write back x squared inside the 4i, and the minus 4i going to cancel off, so that I can just write out as minus 6x. Mhm. Over here now, 3 squared is 9. I'm going to end up with minus 4 squared. So 4 squared is 16. And we'll have to multiply that by I squared, which is minus 1. So what's minus 16 by minus 1?
Minus 17.
Wait, whoa, 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 what?
Wait, what? Sorry, I thought you said that. Okay, sorry, my brain lagged for a second. 16, positive 16.
Oh, how is 9 plus 16?
What?
What's 9 plus 16?
25.
Wait. Emma wasn't there to hear that. I got,
Alright, yeah.
you heard her say, you heard her say 16. Okay, she said 9 minus 16. Yeah, I think she said minus, but minus 16 is 17 or something.
Minus 17.
Oh,
It's okay. We just have too much on our mind.
I see. Right? Does that make the foreheads bigger? Because
Before.
it definitely making my forehead bigger. Like with everything on my mind. So I'm gonna get in parts, right? So 3 squared is 9. It's gonna be minus 4 squared, right? By I squared. And so that's gonna be equal to 9 minus 16 by minus 1, which would be equal to 25. Cool. That's the answer. Realistically, if you're doing this in under exam conditions, you can finish this in under 1 minute. So we go with this question.
How much marks for a
Yeah.
question like that, though?
Like 2 marks.
Oh.
No, it's a simple question. You can't expect much marks, right? Question two is a lovely question. So straight up, they're saying the root of the equation z squared minus p plus I z plus qi is equal to 0. It's 2 plus 3i. So they're giving us one root. Find the values of p and q and find the other root. Now, first things first, straight up. If we are looking at this quadratic equation, right? The quadratic equation here is z squared minus p plus I by z plus qi. Can you tell me what the coefficient for A is? What's the coefficient for A?
1
What's the coefficient for B?
minus p minus I.
Right? Minus, I was going to say minus p plus I, but yeah, minus p minus I. And what's the coefficient for C? Well, not
QI.
a constant, right? Qi. Now, are these all elements of the real number system? Are all of these real?
No.
No. This is not, I mean, this is real, right? One is real. But if you look at minus p minus I, that would belong to the set of complex numbers, right? And qi as well.
Mm-hmm.
Because, so we write our statement, right? B and C are not elements of the real set of numbers. So therefore, the roots would not exist in conjugate pairs, right?
Oh.
Therefore, roots do not exist. So this is how Emma got the question wrong.
Yeah, well, I get it wrong at all.
Ah, if the so straighter, if A, B, and C are not real numbers, then the roots would not be conjugate pairs, right? Just keep that in mind.
Mm-hmm. Okay.
Right. So you understand that the first root in this question, the z1, is 2 plus 3i. Yeah?
Mm-hmm.
Do we know what
Yeah.
the root is?
No.
Nah. But what form would it be in?
X
Well,
plus yi.
You could say x plus yi, or you could say a plus bi. Either one is fine. I'm going to use a plus bi, right? You typically use x plus yi when you find any square root, but it's not wrong, right? But I see why you say x plus yi, because we're already using a to define the coefficient as e squared.
Yeah. Well, that's why I was confused when you told me to use C, like, um, when we doing like the square root thing as well, because C is already there. But yeah, continue.
Right, so we could use x plus yi, but they shouldn't penalize it fit, right? So we can use x plus yi. So Shweta, tell me if you're on board so far.
yeah.
All right. So I'm gonna form an equation here. The quadratic that they gave me was z squared minus p plus I by z plus qi. So Shweta, wouldn't that be equal to z squared minus the sum of the roots by z plus the product of the roots? Yeah or no?
Mm-hmm. Yep.
Right. Now, in this question, they wanted us to find the values of p and q and find the other root. Now, do you think a question would look like this? Be for like 4 marks, and you think you just had to write 2 minus 3i for the answer? Let's be realistic here.
Mm-mm.
No. Straight on, Emma. This question wouldn't be that simple, right? Because you all put 2 minus 3i as the other rootant.
Yeah.
Not that simple. Right, so straight, so you're on board with me so far, right?
Mm-hmm.
Cool. Now, I'm going to write the sum of the roots. Now, the root that they gave me was 2 plus 3i, and the other root, I don't know. You agree? I don't know what the other,
Mm-hmm.
right? I don't know what the other root is. So, I'm going to call that x plus yi because it will be a complex number, right?
All right.
Right? And then the other one will be the product of roots. Now, Shweta, do you think we're allowed to use difference of two squares in this instance?
No.
No, because are the roots conjugate? Are they
No.
conjugates? No, they're not.
Mm-mm.
So you have to take your time and be very careful about this. So you're going to write 2 plus 3i by x plus yi, and you have to expand it. So you're with me so far?
Yeah.
Cool. So this is an instance where you will have to equate like terms on either side. You'll see what I mean by that just now. So I'm going to write back z squared. I'm going to work out the inside. Now, Shweta, I want you to group together the real parts and the imaginary parts. So what are the real elements inside here? Tell me, Shweta, what are the real elements or real parts inside this?
2 plus x.
2 plus x, right? Nice. So I could write that as 2 plus x. Mm-hmm. Okay. 2 plus x plus what?
3i plus yi.
Right. Let's
Right.
factor the I one time.
Yeah, so I'm gonna say, you could put 3 plus y by I.
Mm-hmm. Right. So I could write,
But I have a question because isn't z equal to x plus yi? Why we put in I is x plus yi?
wait, say that again.
So in the sum of roots, well, we know. So you said p is basically 2 plus 3i and I is x plus yi?
Waiter. So, Emma, this is what we were given, right? And I'm forming an equation over here. Remember from last class, I showed you that for any quadratic equation, we could express the equation as z squared minus the sum of the roots plus the product of the roots,
Yeah.
right?
Okay.
So we knew what the first root was. The first root was 2 plus 3i.
Yeah.
The second root, we did not know what that was, but we know it will be in the form of a complex number. So x plus yi.
Oh no, okay. I was watching the quadratic and then watching what you wrote next. And I think I get confused.
All right, so you understand that a forming, so this
Yeah.
was any question, right? And on the other side, I'm forming a quadratic equation using the information they gave us.
Yeah.
So they told me that this was the first root and we didn't know the second root, so I just called it x plus yi.
Yeah.
If you have the roots, you could find the original equation by finding the sum of the roots and the product of the roots. So the sum of the roots would be 2 plus 3i, the first root, plus the second root, which is x plus yi. Yeah?
Yeah.
And then the plus the product of the roots, right? So 2 plus 3i by x plus yi. Say with me so far.
Yeah.
Right. You'll see where I'm going with this.
And I feel like I just tripping this.
All right.
Because we do it over again, but yeah.
Say with me so far.
Yeah.
All right. Let's expand this out now. So we could come to the side and do it. Or would you all just prefer to do the next line? I don't
No,
want.
I could just do the next line.
All right. So 2 by x is 2x. 2 by yi is 2yi. 3i by x is 3xi. And then we're gonna end up with 3 by y, which is 3y, and I by I, which is I squared. What's I squared, guys?
Minus one.
Minus 1.
Why you see it like that?
Sorry.
Minus 1. All right. Yeah, I really should have put this on the deadly question, I really should.
Yes.
Right. Yeah. Okay. I'm just gonna write this back and do one more line of simplification and then equate parts. All right. So we need to group together the real parts and the imaginary parts for this. So that 3y by minus 1 is going to turn to what, guys? What is this 3y by minus 1 going to turn to?
Minus 2i.
It's going to turn to minus 3y. So could you group together the real parts for me?
2x minus 3y
All right.
plus in brackets 2yi plus 3xi.
Right. So I'm going to write 2y, 2y. plus 3x I. Did that confuse you, Emma?
No.
So everybody, like are they with me, right? Like everybody,
Yeah.
nice.
Yeah.
Mm-hmm.
Can you all see that we have a quadratic on this side? This is the form they told us it would be in. And we form this quadratic with the information that was given. So on either side, we have we have quadratics. All I agree.
Mm-hmm.
All right. So Shweta, you see z squared lines up with z squared. Cool. This lines up with this.
Yup.
So essentially, you would say p plus I is equal to what? Well, check it out. Minus z. So we're
Mm-hmm.
looking at this.
It'll be open brackets 2x close brackets plus open brackets 3a. Yeah.
So that whole thing over there, right?
Yeah.
All right, nice, nice. Emma, now
Yeah.
we're going to look at the constant part of it. So wouldn't this be the constant part,
Yeah.
right? And the constant part for this one is qi. So we're gonna write qi is equal to what?
That whole pink and blue thing there.
Right? Now this question kind of tricky, yeah? Because a lot of students might know where to proceed from here. Right. So Shweta, we want to equate the real and imaginary parts. So if you're looking at this,
Uh-huh.
what's the real part over there?
The real part is p
Right? And what's the real
and
part over here?
2x. Yeah, 2 plus x.
Right. So we could form that. We could say, right? So we're going to equate the real part. So this is the real part. This is the real part. The real part would be given by p is equal to 2 plus x. Yeah?
Wow. Yes.
The imaginary parts.
Oh my God.
Oh my God. Oh, I use a very gill pop color over here. Pink. This is a very gilly pink
You know what it given? It given soda pop.
soda pop.
You know this song?
Nah.
My Little Soda Pop.
Oh yes, yes, yes. I know.
Yeah, yeah, yeah.
Now let me see how bad it is, right? Let me see if I could figure this out. What am I gonna put right? What am I gonna write for the imaginary part?
3 plus y. Oh, y is equal to minus 3.
No,
No.
no, no. Wouldn't write that.
Three, 1 is equal to 3 plus y?
Yes, yes. Let me show you something, right? So Emma, isn't this one eye?
Yeah. Oh.
Imaginary one.
Right.
Oh. Oops.
So we're going to say one, one is equal to 3 plus y. So
Oh.
I just put on this in here. You're not seeing it, but this is understood to be one eye, right? So one. So I hope we okay. We okay with this?
Mm-hmm.
Yeah.
Nice. Let's do it. Let's do the same thing for this. Now, guys, I might lose some out here, right? But let me show you something. If we look at the left-hand side, are there any real elements?
Nah.
Mm-mm.
It'll
So,
be equal to 0.
right. So we're gonna write 0 plus qi. I'm gonna write
Yeah.
right. And so tell me, if we are equating the real parts, let me just copy and paste this because God knows I'm too lazy. All right. Right? Yeah. So what would the real parts be equal to? We would say 0 is equal to what?
2x minus 3y.
Right? And we would say what for the imaginary parts?
U is
Q.
equal to 2y plus 3x.
Lovely. Now we are looking for two equations with just x and y in it, so we could solve simultaneously, or we're looking to see if we have any equations we could solve immediately. Are you all seeing any equations that we could solve immediately? I'm seeing it. So we generally have four equations here, right? We have this one,
The 1 equals the 3 plus 5.
Yeah, we could solve that immediately, Ends.
Yeah.
Right, so let's solve it immediately. If I solve that, y would be equal to 1 minus 3. Did I confuse you?
No.
All right, so y would be equal to what?
Minus
Minus
2.
2.
Nice. Y is equal to minus 2. So we have this piece of information. Which equation could we plug this into to find for something else?
Make a
3.
put into equation 3.
Yeah, I could, because equation 3 has the unknowns x and y. We know what y is, so that will leave us with one unknown. Right, so 0 is going to be equal to 2x minus 3 by minus 2. You end up with 0 is equal to 2x plus 6, not minus 5-ish, Rita.
You're going to confuse me now.
All right, everybody okay with this? Are they understand?
Yes.
Right, nice. All right, I'm gonna move across the 6, so I'm gonna end up with 2x is equal to minus 6. Are you all confused?
No.
All right. Then I will do what on both sides.
Divide by 2.
So you're gonna end up with minus 6 over 2. So x is equal to minus 3. Now that we have x and y, and we can figure out 1 and 4.
Yeah.
Yes, we could. So let's do that. So 1 is p is equal to 2 plus x. X is minus 3. So p is going to be equal to 2 minus 3, which is just minus 1.
Wait, I got that.
You did?
Yeah, I do my weird comparing. I'm thinking I get -1.
Well, big up you, right? And for the imaginary part, q, right? Q would be equal to,
Get that, pray for me. Pray for me.
right?
Om.
Plus 3 is it Om Pratanam Pratanam.
Om Pratanam Pratanam Samgamaya Tam Soma
Come
Jyotirgamaya
on,
Nityama
manifest
Anantam
minus.
Gamaya Om
It is minus
Shanti.
13. It's minus 13. I did it. I did it, sir. I'm not stupid.
Do not redeem it.
I did it.
Big up you. I had to check your working.
Look at it. It's real ugly.
Right? Oh, by the way, guys, we didn't finish the first question. I realize that. If you write this for the first question, you're gonna lose 1 mark.
I
Why?
didn't write what H and K is.
Yeah, you never specify what H and K was. Right?
Oh,
So H would be, I don't remember that. H would be equal to minus 6, and K would be equal to 25. Yeah. If you leave this out, you're gonna lose a mark. Yeah. Right? Okay, so to put the icing on the cake, we need to find the values of P and Q. Well, we did that, right? So P is equal to minus 1, and Q is equal to minus 13. And guys, and we could write the complete equation if we wanted,
yeah.
Yeah.
right? So the complete equation would be z squared. It was
Minus
minus
in
I,
brackets.
right? Minus in bracket.
Emma's really happy that she got her 13.
Yeah,
Plus,
big up Emma for real.
no, because I was just in the car. Wait, it's supposed to have a Z next to that bracket.
Plus Q. Wait, have a I. We're not supposed to have a I.
It's supposed to have an I and then a Z next to the middle part.
Right. Mm-hmm. Right.
I'm so happy. No, I was feeling so dumb when Sir told me I got it extremely wrong.
That was the first rounds. That was the first rounds. That was the first rounds. Because I was preaching last class that is it will only exist as conjugate pairs when A, B, and C are real numbers. If it's not real numbers, then it wouldn't be in conjugate pairs. I make sure and preach that. Like I could count how much times I write it. Wait, I have it over here. A, B, and C had to be real. A, B, and C had to be real. Given any quadratic equation where A, B, and C are real numbers and the roots occur as conjugate pairs, yeah, I really say it.
I'm, I'm sorry, sir.
That's okay. That's okay. Just don't make that mistake in the exam.
We had to burn to learn. Now we know we have to make sure A, B, and C real.
Yeah, if not, pressure. You have to do something like this, right? And they want you to stay the other roots, right? So the other root will be x plus yi, right? So the other root would be equal to, so we got x to be minus 3, so that'll be
So
minus.
your wicked makes more sense.
It makes more sense.
Your wicked makes more sense. My wicked. It's probably my handwriting that making it look ugly.
Probably. I will check your working, right? I'll check your working. All right, so everybody understand what I did for this question?
Yeah.
Okay. Was
Oh, wait, that's all he had to do to find the other root? Wait,
Yeah, because remember, and we had said at the start that the other root would be in the form x plus yi.
okay, so
Mhm.
don't watch my wicked.
I'm going to no. Let me check what's going on here.
Wait,
Guys,
how
give
did
me like 2 minutes. I'll be back.
All right,
Yeah.
let's see what you do, Emma. Ain't no way. Ain't no way. Bro, what?
Okay, just watch the first part.
Bro, like, if you do that, then you're supposed to get the correct answer, though. Yeah, you're supposed it's yeah, Emma, if you did it like that and you did everything correctly, you're supposed to get the correct answer. Supposed to. Yeah, so
I'm trying.
something went wrong along the lines there, but yeah.
I don't know what I did wrong because I feel
Let me see what
like,
so you said
is it because I put minus 13 and I didn't put minus 13i? I think that's why.
yeah, that's why. That's why. Because
But
minus 13 now is the whole number there. Is the entire number. But looking at you working, trying to understand you working. Right? So you have it looked like you do factor theorem,
yeah, I did.
which is fine. That's fine. Because if you're telling you it's a root, obviously it'll be a factorand.
Yeah.
Because roots
And
come because you get a root when you factorize. That's the whole point of our roots.
you showed me piece of your weekend, and I saw the sum of roots and the product of roots, but I didn't understand like how I was supposed supposed to do it. So that's why I end up doing it like this.
No, but that's a good method. It's just when you do like that, you wouldn't see like you could do all that, right? But you wouldn't see a clear like when you do like this, it's obvious to you what the second root would be. But I like your method. I like your method. And well, truth be told, let me see if I could tell you like a easy way to get your roots from here without having to do the quadratic equation. Let me see if I could do that. See, you said,
Before you do that, you can just show me how you got Z2.
all right, so remember how we made an equation in terms of the root that they gave us and the root that we assumed,
Yeah.
right? So once you make an equation in terms of what the root that they gave you and the root that we assumed, right? We assumed, right? Because if you have a quadratic equation whose essentially what I'm trying to say is if the roots are complex numbers, then both roots should be complex numbers. So we assume that Z2 would have to be in this form. So you understand how I come up with the equation,
Yeah.
right?
Yeah.
And you understand how I equated the real part, the imaginary part, all of this stuff.
Yeah.
All right. Remember the starter said Z2 would have to be in the form x plus yi,
Yeah.
and I formed my equation using that x plus yi. And so when you solve everything, you got you first got y to be minus 2, then you plug that into 3 to find for x, right? And well, that's all. That's all you really need because and we said the second root would be x plus yi.
Yeah.
So we have x over here, we have y. So I would just say so x plus yi, x is minus 3, right? And y
Mm-hmm.
is minus 2, I. So that'll be minus 3 minus 2i.
Okay.
You still confused?
No, I'm good.
Shweta, I want to show you how Emma did it. It's like really smart. It's like really
Mm-hmm.
smart. She did it. She used factor.
Ooh,
She used factor theorem.
okay.
Completely fine. You think outside
Genius.
that one. Big up yourself.
Mm, big brain energy.
And I go into Emma. I think I have a way to do this in my head, like without having to do the quadratic equation. I think I have a way to figure it out. Right? I'll show you. I think I have a way to figure it out. So Shweta, and roots. And to find a root, you'd factorize a quadratic.
Yeah. Mm-hmm.
Yeah, like let me give you a very simple example. If I had x squared plus 5x plus 4, and to find your roots, you would say x, it would be like x
Mm-hmm.
plus 1 plus 4. And you would do that.
Mm-hmm.
And then you would say x is equal to minus 1 and x is equal to minus 4. Yeah or no?
Mm-hmm. Yeah.
Right? So in other words, straighter, and x is equal to minus 1 would be a root,
Mm-hmm.
and x is equal to minus 4 would be a root.
Mm-hmm.
So in other words, straighter, and x is equal to, okay, if you have x is equal to minus 1, and according to the factor theorem, if I plug that into the quadratic, what's supposed to get?
0.
I'm supposed to get 0. That's what Emma used. That's what Emma used. Because Shweta, Ender gave you one of the roots in the question.
Ew. Okay. Mm-hmm.
So if I plug that root into the quadratic equation, it's supposed to be 0, right?
Mm-hmm.
You understand what I say?
Yeah.
All right. All right, so you see how Adman's coming to haunt all you? Well, not haunt all you, all you was good in Adman, so it already how much to haunt. Right, so using factor theorem, I like this approach. So we're just gonna plug 2 plus 3i into it, and it will have to be equal to 0, right? So it's gonna be 2 plus 3i squared minus p plus I, right? Open bracket, 2 plus 3i, close bracket, plus qi, and that has to be equal to 0. So Shweta, you understand what I'm saying?
Mm-hmm.
So
Yep.
Shweta, in the question, and they give us one root.
Yep.
Good. So if they give us one root, then and when I plug that root into the quadratic equation, and it's supposed to give my value as 0 because it's a factor of the root, it means a factor of the equation.
Mm-hmm.
You sure you with me? I'm not losing your time.
Yeah. Okay, yeah, we plug in that one root and it's supposed to
It has
give me 0, but because it's in wait.
no, it wouldn't give you 0 because you don't know what p
Yeah, because it's in terms.
exactly. So by doing this, and we form an equation,
Yeah.
right? So 2 plus 3i squared, right? That's gonna work out to be 4, right? 4 plus that'll be 4 plus 6i, would it?
No, I think it's 9.
Wait, let me just do the whole thing. So that'll be 2 plus 3i, 2 plus 3i. I think you're talking about the final term, man. I'm talking about the middle term. If you would,
Oh yeah, I was talking about the final. The
it'll be 12, it'll be
three
12.
eyes.
2 by 3 is 6i, and then 3i by 2 is 6i again. then 3i by 3i, like you said, that'll be 9. But you have to take into consideration the I squared, right?
Mm-hmm.
So 9 by minus 1 is minus 9, right? So you're going to get 4 plus 12i minus 9 over here. You with me?
Mm-hmm.
Right? And for this one, it's going to be minus 2 by p is 2p. P by 3i is going to be 3pi. Then 2 by I is going to be 2i. And 3i by I is going to be minus 3. Yeah?
Yep.
Plus qi is equal to 0. We could simplify the real parts over there. So 4 minus 9 is minus 5. Minus 5 plus 12i. We could simplify inside first. So we have, so Shweta, any real parts there would be 2p and minus 3. Inside
Yes.
2p minus 3, right? And the imaginary part would be plus 3pi plus 2i, right? Plus qi. All right. You'll see where I'm going with this. So minus 5 plus 12i, that's going to give me minus 2p plus 3 minus 3pi minus 2i plus qi is equal to 0. Okay, Shweta, is it possible to group together all of the real and the imaginary parts?
Yeah.
All right, let's identify the real parts first. So minus 5, then plus 3, right? Minus 5 and plus 3 is what?
-6.
Whoa,
Wow.
whoa.
Oh, sorry. Sorry. I thought you said -5 and -3. Sorry.
Even if I
Um.
even if I said
Oh,
minus 3, that'll be plus 15.
5 and 3?
Yeah, minus 5 by minus 3 is plus 15.
What? No, no, no. I thought you said -5, -3.
Oh,
And when you said the +3, I end up watching the -3 by the PI. And I say -8. Anyway, so it's -2.
minus 2, right? Mm-hmm. Minus 2. The imaginary parts is, so okay, we have 12i minus 2i. We could work that out first. What's 12i minus 2i?
Can I?
Right? But wait, we have another real part. I'm not sure if you've seen it, but we also have minus 2p. See that?
Uh-huh. Okay.
That's also a real part.
So what was the
Mm.
answer?
The answer for what?
The same question you did, like the way you did it.
The answer was minus 3 minus 2i for the other root.
Yay!
You get it?
I got 2 plus 3i and minus 3 minus 2i, but I got minus 3 minus 2i.
Nice. I will show you a way to do it without using the quadratic formula. You see how easy it is. Right. So Shweta, let me continue, right? So we group together the real parts. Before we do anything, we have 12i, right? Minus 2i. Yeah.
Mm-hmm.
What is 12i minus 2i?
Can I?
10i. Mm-hmm. So we have plus 10i, and we have minus 3pi plus qi. And we can agree that all of those things have I in it?
Yeah. Ik can factor it out.
Yeah. So I could write plus 10. Wait, what's it? I could write plus I, and in brackets, I'm going to write 10. I'm going to write minus 3p, right? Minus 3p plus q. I'm gonna if you're okay with that.
Yep.
And that's equal to 0. So I'm gonna figure with that.
Yes.
All right. Emma, you go with that?
Yeah.
I do this slightly different from you, right? Slightly different from you. Right? So you have 12i, yeah, 12i minus 2i is 10, right? Then you have minus 3p plus q, have your I on the outside. Cool. Now, Shweta, if you look at the right-hand side, we have 0, right?
Yeah.
So what would that mean for the real and the imaginary parts? If it's just 0, what would that mean?
Both had to be equal to 0.
Right, so and I could write that as 0 plus 0i.
Yeah, okay, yeah.
Yeah, because n 0 by n.
Yeah. Mm-hmm.
Yeah. So if that is the case, we're going to equate the real and the imaginary parts. So Shweta, the real part here is minus 2p n's,
Mm-hmm.
and that's going to be equal to what?
0.
Right? If I move across the negative 2, that's going to turn to plus 2. I will divide both sides by negative 2. And so p is going to be equal to what?
Minus 1.
Right. So that's the first answer over here. Right? And what would 10 minus 3p plus q be equal to?
0i.
Not just 0,
0.
because remember, factorial I. So
Mm-hmm.
look at the coefficient. And didn't we already find for p?
Yeah.
So we could write that as 10 minus 3, 10 minus 3 minus 1 plus q is equal to 0. And I can write that as 10 plus 3 plus q is equal to 0. And if I group together 10 plus 3, that's going to be 13. And if I move across that, it's going to be minus 13.
Minus 13.
Yeah. So
Right.
big up, Emma. Emma, I would not see it like this. It's bad, it's bad. Yeah, and it's shorter as well. Right?
Well, it made this bad shorter, so you have to do the long quadratic formula.
No, I'm gonna show you a shortcut. At least I think it's gonna work in my head. I didn't try it before. I think it's gonna work. We're gonna see, right? So if since we know this, right? And we could write the complete thing.
Yeah.
Yeah. I could write the whole thing, right? So Shweta, if I know what P and Q is, tell me what the entire quadratic would be. That would be z squared minus.
Z squared minus open brackets minus 1 plus
We could
is it
just,
I?
yeah, minus 1 plus
Yeah.
y.
Close brackets by Z plus no minus 13i equals 0.
All right, so am I your mind ready to be blown?
Yeah.
Okay, so I'm going to essentially utilize what I did in the last question. So check this, right? If I change this to a plus over here, wouldn't that make this 1 minus I by Z?
Yeah.
You're sure I'm not confusing you, right? You with me so far?
Yeah, I'm good.
All right. Isn't this part equal to the sum of the roots,
Yeah.
right? So look how we're going to do, right? So we know that this is the sum of roots. Sum of roots. Don't we already know what one of the roots are?
Yeah.
What's one of the roots?
2 plus 3i.
All right. I think you're gonna see what I think you can see what I'm gonna do, right? So 2 plus 3i plus sum plus z, right? Plus z, right, is gonna be equal to 1 minus I. Tell me if you're with me so far.
Yeah.
Right?
Wait,
Z is just the other root. You can call it Z2 if you want.
okay,
So guys, remember,
okay.
so they gave us Z1, which is the first root,
Oh
and
my God.
I added Z1 and Z2 together, and that should be 1 minus I. So if I do that, the Z2 should be equal to 1 minus 2, right? Plus 3I minus I. And
Mm,
minus 1, wait, plus 2I. But wait, that giving us a different answer.
yeah.
Something is up. It's supposed to work. It's supposed to work. Give me a second. Unless we're supposed to form simultaneous equations. Give me a second, right? So we can write as 2 plus 3i, and that'll be x plus yi. Give me a moment. It's supposed to work out. Let me try to figure that one. This will be the product of the roots, right?
Yeah.
So minus 13i would have to be equal to 2 plus, that's 2 plus 3i by the other root. Gonna call that x plus yi. And how to work out? Like, how to work out? If it don't work out, I'm gonna lose my mind, right? I could also write this as 0 minus 13i. So
Yeah.
I could, if I expand, this is it's gonna be 2x, right? Right, thanks. That's gonna be 2x plus 2yi plus 3xi plus, no, it's actually gonna be, that's gonna be minus 3y. Are they with me?
Yeah.
All right. Are they sure? Should they with me?
Yeah.
2x
Uh,
plus 2yi plus 3xi, yeah, minus 3y. And that's gonna be 0 minus 13i. All right, so if that's the case, 0 would be equal to 2x minus 3y
this is what you ended up with before.
with,
Oh.
you're essentially doing the same thing, right? More or less. So 0 is equal to 2x minus 3y. Okay. I just hope you get the answer. Right? 2x minus 3, that's the real part. And then the imaginary parts would be minus 13 is equal to 2y plus 3x. Yeah or no?
Yeah.
Yeah.
Okay. Let me just verify that. So 2y plus 3x is equal to minus 13. Let me just solve this thing simultaneously first. So we have 2x minus 3y is equal to 0. And we have 3x plus 2y is equal to minus 13. I can multiply this by 3 and I can multiply this by 2. So that's going to be 6x minus 9y is equal to 0. And this is going to be 6x plus 4y is equal to minus 26. So that's going to be minus 13y minus, okay, I like the way this is looking. It's going to be minus 13y is equal to plus 26. Am I seeing light at the end of the tunnel?
Yeah.
Yeah, I see that. I see that. Right? And if that's the case, then, you know, then y will be equal to what? What phrase?
-2.
Right? Yeah. So y is equal to minus 2. And what would x be? You could use any equation you want really to find from which equation you want to use to find for x.
The first one.
Right? You can use the first one. And so it would say 0 is equal to 2x minus 3 by minus 2. And you would end up with this going to the plus 6. And when you move it across, you're going to the minus 6. So 2x is equal to minus 6. When you divide both sides by 2, it's going to turn to what?
-3.
All right, so x is equal to minus 3. And when we switch,
Yay.
and we have said that the other quadratic would be uniform x plus yi.
Yeah.
So
Uh-huh.
final answer for the other root will be x, which in this case is minus 3, right? Plus y, that's plus minus 2 is minus 2i. And that's the answer I suppose to get.
Yeah.
I wonder,
But
I wonder why they work for the first one.
yeah.
I'm not gonna stop until we figure it out, right? So,
But still, I still got even when I did the quadratic rule thing, I got 2 plus 3i and -3 minus 2i, so I think you would get a different answer anyway.
hmm. Well, 2 plus 3i is the original root, yeah? As one root, and the other root is minus 3 minus 2i,
Oh yeah.
right? So let me just check back this. So the sum of the roots supposed to give you 1 minus I. Like mathematically, it's supposed to. So we have 2 plus 3i, that's the first root, plus the second root, which is in the form x plus yi, and that's supposed to be equal to 1 minus I. Did I do anything wrong here? I don't think so.
No.
Plus here, 1 minus I. Makes sense. And when I add up that, I'm supposed to get 1 minus I. All right. Let me just continue with this and see. We should get the answer. We should. We should. So, Shweta, what are the real parts over here?
2 plus x.
All right. So, 2 plus x is equal to 1. You understand how I get?
Mm-hmm.
Okay. And I would say 3 plus y is equal to.
Minus 1.
So, x would be equal to 1 minus 2.
Minus 1.
But, like, hmm, wonder why that's that happening, boy. Wonder why. And for over here, we're going to get y is equal to -4. That's strange.
Very.
That's really weird. I don't get it. That's not very slay. Mm.
Maybe quadratic is the only answer.
Oh, we get with this. We get with the product and roots. So something,
Oh, we didn't get to this sum.
yes, something kind of sus here. Oh, I know why. I know why, guys. Oh my gosh. Oh my God. I'm so stupid. Wait, watch this, guys. Watch this. Watch this. If we want to do that, nth in the sum and product form is z squared minus the sum
Uh-huh.
plus the product.
Yeah.
So
Uh-huh.
why are I going on turn this a positive on the outside?
Uh.
I, I
Okay.
don't know if I just see what I'm talking about.
Yeah, I understand.
Straight up, what I'm saying, right? Straight up, the whole thing we're trying to exploit over here is that
Oh,
is that if it's in the sum and product form, it has to be a minus sign in front of here.
yeah, you just taking you're just using what in the bracket here now expanding it out.
Yeah, you know. So now it should work, right? Now it should work 100%. Like, you have to work. Otherwise, I'm going to drink Grandma's Own tonight.
Valid crash out.
Right? So you would say 2 plus 3i plus the other root, which is x plus yi, and that would be equal to minus 1 plus I. And so if you equate it one time, you'll get 2 plus x is equal to what,
Unit.
right? And then you're going to get 3 plus y is equal to 1. And so x would be equal to minus 3, because you move across the 2 to into minus 2. And you move across the 3 here, and you're going to turn to 1 minus 3.
Yay.
Like, this real short, though. Like, this real short. Wow. Yeah. Sure, are you happy? It worked out?
Yes.
I don't have to drink Amazon.
Mm-mm.
Yeah, just please be wary of that, right? If you want to do this, it has to be in the sum and products form, which says that z squared minus the sum of the roots minus the product. Has to be in this form for it to work. So if that's the case, then the other root, z2, will be equal to x. X is minus 3 plus y, which is minus 2y. So Emma, if you did your method, all you had to do was just do this and you get your answer.
Yeah.
Or you could do this, but I wouldn't recommend it.
Yeah.
So straight up,
You say you wouldn't or you would?
I wouldn't, because come on, like, okay, straight up, what you rather do? You rather do this or do this? You're getting the same answer.
I prefer the sum.
I prefer the sum as well. Just don't forget the negative on the outside. So yeah, you sure you understand it?
Yeah.
But when you look at it, it's more or less the same working, but this looking like more working, like objective.
Yeah.
This looking like less working. Let me take a picture of this to scare the Form 4 and Form 5 students.
So you could take a picture in your tablet.
Say that again. Take a picture.
You could take a picture of like the class with that zoom in and you could tag me on your story or something.
Yes. So yeah, straight. So I'm trying to make the notes aesthetic, even though it's white. You know, we prefer the black, but like,
Yes. Yes, yes, yes.
so I laugh for the joke.
I'd laugh.
This is a recording. I probably shouldn't make jokes like that.
Oh, white supremacy.
Yeah. It's like kind of like I don't want to cancel myself. I don't want to delve deeper into that statement.
We're gonna show this recording too. It's only gonna be me and Emma if we had to watch back anything.
Well, I'm gonna post it on my YouTube channel. And like, but yeah, I could just put it unlisted. But
If
the problem with me putting it as unlisted, right? If I lose the link, I'll be screwed because I'm only gonna find it on YouTube. But like if
Oh,
I
shucks.
my YouTube channel on public, like I could always go back to the YouTube channel and look for the video and find it. But if it's
S-
unlisted, you gotta message me and be like, so you can send that link. You understand? If you lose it,
Yeah.
I just
that
Or you could make like a unlisted playlist and send like send the link.
I could do that.
that's what
Um
Mr. Ambert did with
yeah.
us.
I just do that for my form 4 students actually. My form 4, my form 5 students. Yeah,
Nice.
YouTube is just be giving out free storage, dog. I love YouTube for that. Right? Like you could upload anything on YouTube and just have it there unlisted. It's like Google Drives. When you think about it.
Yeah.
Mm-hmm.
All right, so everybody understand the trick question, question two.
Mm-hmm.
Yeah.
Big up Emma one time. Big up
Mm-hmm.
for the awesome minusing.
Um
That's very swag. Wait, I have a perfect sticker for this. Straight, I have a perfect sticker for this.
oh gosh.
Wait, wait.
Should have a oh,
Oh my gosh.
I'm gonna read.
there's a part of complex numbers that I find a little confusing because they bring in like tricks into it too with the Morpheus law.
The Morse theorem. Right there. Let's get some trouble.
Yeah. Well, I honestly didn't do any questions. I was just watching what Miss was doing and I was feeling confused.
Don't worry. It's not that hard. I will show you how they come up with it. Like, trust me, Emma, I will show you how they come up with it, and it'll be like, oh my God, this is how this works? Yeah, yeah. Right. So question three, find the square root of 4 plus 2 root 5i. Right? So this is an easy question. So straight out we do this question. Let's speed on this question. So if you find the square root of a complex number, obviously your answer has to be in the form of a
Wait, say that one?
straight up. If you find the square root of a complex number, then your square root has to be in the form of a
Complex number.
right. If you find the square root of a real number, obviously you're gonna get a real number. So yeah. So if you find the square root of this, let me use green, right? I you notice I use some like typical whiteboard colors, like like green, red, the blue.
Yeah.
Yeah,
Mm-hmm.
it's kind of like writing on a mini whiteboard, right? And that should be equal to what theta? What should it be equal to? What form should it be in?
X plus 1y.
Right. So to get rid of the square root sign, we're going to square both sides. And I'm going to end up with 4 plus 2 root 5i. That's going to be equal to x plus yi squared. Uh-huh. And if I expand that, what I should get? Should get x squared plus
Minus. Oh, okay, okay, he went, okay.
2xyi, right? Minus y squared. Somebody could confirm that?
Mm-hmm.
Yeah.
Yeah, okay. And now we're going to group together the real and the imaginary parts. So I'm gonna color code it, right? So that's a real part over there, and this is a real part over here. This over here, this is the imaginary part, and this is imaginary over here. This look like a flag. Like look, it look like a flag.
Which
The color coded.
Yeah, it look like a flag.
Oh,
Yeah.
isn't it like the pan flag?
Yeah. It's a pan flag.
oh shit. I
Like
thought it was a trans flag. Oh gosh.
no, because it's the white, pink, and blue.
Oh, okay.
Yeah.
Mhm.
As you all can see, I don't discriminate. I,
Mm,
I used to write on a black background, now writing on a white background,
mm.
black background. Like I using multiple colors. Sometimes my nose is like a rainbow. I don't judge. I don't judge.
That's plus ultra of you.
Yeah. I don't judge nobody, right? I, I
Oh
mean,
no, Shweta's right. It's the trans flag.
it
For
is.
real?
Yeah, the
But
pan flag has yellow in it. The trans flag has the white.
oh,
It's
okay.
basically the same flag.
All right.
It is split up the colors.
Well, let me continue, right? So,
You actually got and set it up.
I just not such luck, right? So the real parts, that's going to be 4 is equal to x squared minus y squared, right? On the imaginary part. That's kind of like when somebody asks you if you have um a second half, and they'll be like, no, it's imaginary because it's a imaginary part, because like it's single. Can't be,
Oh.
can't be me. Could never be me.
So you're clocking me.
Sorry. Imaginary parts, right? Unless you be focused on the books, what do you mean? Hey,
Hey, so that's nothing, right?
that's okay. When I was in Form 5, I had very, yeah.
What?
I helped actually, I helped my girlfriend get one in maths. And she actually got a distinction in maths. I helped her.
Hey,
So sometimes,
Ray.
not all the time, our relationship is bad. Not all the time. But you had to make sure if you go into a relationship with somebody, you had to make sure they know how to do this expansion, right? Like you make sure that they know how to do this expansion. If they say a squared plus b squared, bond that one.
But not bun that bun them.
Yeah, bond them one time. But
Oh my gosh.
if your significant other can't do that, then what? But what? If by doing that, you're lowering your next like your future child's IQ by like 15
Oh
points.
my gosh. That's such a good point.
Yeah. You don't want your child to also count the legacy.
Ah, ah.
Right? So the imaginary part is gonna be 2 root 5. After class, I'm gonna make sure my girlfriend can do that.
Well,
I will let
so
you
if she can't, I don't think you could really do anything in that situation. You just had to.
Be quiet.
Yeah.
stay posted for update, guys. Stay posted for updates. Like,
What?
stay posted for updates.
Post it for updates.
Yeah, I'm gonna see if she could do it.
Oh,
Right. So let me continue, right? Now, in the imaginary part, I have 2 root 5 is equal to 2xy. I could divide throughout by 2, and I'll just end up with xy is equal to root 5. Yeah?
mm-hmm.
Are you okay, right?
Yeah,
Yeah.
yeah.
This equation 1, this equation 2. We should probably make a third equation. What do you want to make this third equation using?
Why?
This one which equation? 1 or 2?
Oh, two.
2. Right, so you will say, so equation 3, that's going to be y. Is a different color? So y would be equal to what? Root 5 over.
X.
Right. Gonna plug that into equation 1 now.
Wait, so you could scroll up for a second. Spell
Okay,
it again.
1 second. So that's gonna be 4 is equal to x squared minus y squared. Now we found y to be root 5 over x. Gonna make that substitution. And I'm going to square that. All right. Shiza, you done?
Yeah.
Okay, cool.
So you know how you gave Shweta like a second to watch it today in class for physics? My one of the girls in class asked Miss for a second to write down the notes, and Miss was just like, "One, you don't know, Gabby."
Oh, and imagine if physics teachers on SI units don't play. Like I would be like, Miss, give me 300 seconds. If I was a physics teacher and you ask me for time and minutes, I'll be like, one you. Like, SI units strictly in this class. Where you get minutes from? Seconds. Seconds. Yeah. Next time my students ask me for time in physics class, I'll be like, no, give me it in seconds. Convert it to seconds and then I'll listen. Like that. It's an easy conversion though, 5 minutes, 300. If they can't do that, I'll cry.
My
Ah,
my my chemistry teacher keeps sending us like these motivational things.
that's like them old aunties.
She
Like,
is.
oh, well, that's wholesome, eh? I'll say it is very wholesome. Until the WhatsApp images like good morning and thing.
Yeah.
Yes.
Oh God, my mother just
I
be
know
saying,
it. I know it all too well.
boy, oh boy. So let me continue, right? So I plug equation 3 into equation 1. Yeah.
Mm-hmm.
Yeah.
So now we're going to simplify. So straighter, we're going to put 4 is equal to x squared, right? I'm going to square all of the elements there. So that's going to, our root 5 is going to turn to 5, and our x is going to turn to x squared. So yeah, we don't like working with fractions, so we had to multiply throughout by what?
X squared.
Right. Right? And you're going to end up with, hey, what I going to put it in the form of a quadratic one time, eh?
Yeah.
So you're going to end up with x to the power 4, right? Minus 4x squared, right? Minus 5. I think that's it.
Mm-hmm.
Let me just verify that one more time. So x squared on this side, that one to the x to the power 4. Then when I move this across, I'm going to set to minus 4x squared. And this goes to the minus 5. So that's correct. Right? Now we're going to say let x squared be equal to what? What do I want to use?
A.
Now let me use t.
T. Okay.
Right? So x to the power 4 going to turn to t squared. Right? X squared going to turn to t. I'm just going to turn to minus 5. Well, it was already minus 5. Nothing going to change. And so we're going to factorize this now. To get t squared, that's going to be t by t. We're looking at a number that would multiply to give us minus 5, but add to give minus 4. So I can use what? What two numbers I can multiply to get minus 5, but add to get minus 4?
1 minus 5.
Right. So plus 1 minus 5. When you find for t, you're going to get t is equal to minus 1, and you're going to get t is equal to 5. Which one is valid though?
T is equal to 5.
Right. This is, remember, um,
He no real.
x, if we look at the original form, right, guys, and x has to be at the real part.
Yeah.
Yeah, x can't be imaginary, like your other half. Sorry. I don't mean that. I don't mean that. I think I'll come soon, madam. Right? So remember we said x squared was equal to t. So if you go to find for x using this, it's gonna be imaginary. That can't work. We can find for this one though. right? So x squared would be equal to 5. And anytime you find square roots, how much solutions you're going to get?
2 plus or minus.
Right? So x is equal to plus or minus root 5. We okay with that?
Mm-hmm.
Right. And so let's look at the positive one first. So x is equal to root 5. If x is equal to root 5, you plug that into y, and that would be root 5 over root 5. So y is equal to what? What is root 5 over root 5?
1?
1, right?
Yeah.
And when it's negative, it would just be what?
Minus 1.
Minus 1.
Yeah, that'll be root 5 all over negative root 5. Bro, right, root 5. So y is equal to minus 1. Right, so the answers for this is going to be, so z1 is going to be, so x plus yi. So that's going to be root 5 plus, plus, right? So plus 1i. I can just write I. Everybody okay with that?
Mhm.
You guys good?
Yeah.
Right, and z2 is going to be what?
Minus root 5.
Yeah, minus root 5.
Minus.
I'm going to show you something that's going to blow all your mind, right? It's going to blow all your mind. And when you find any square root, you're going to get a plus or minus solution.
Yeah.
Watch this, eh? Watch this. And if I wanted, I could have factor out the negative term here, and that'll be minus root 5 plus I.
Mm-hmm.
But when you find the square roots, and to get in plus or minus root 5 plus I,
Mm-hmm.
Yeah.
yeah. A little song don't like at the start, right? Like, okay, definition of square root. And when you find the square root of any number, you get two solutions.
Mm-hmm.
Yeah.
And we're trying to find the square root of this number over here.
Mm-hmm.
So anytime you're trying to find the square root of any number, be it real or complex, you're always gonna get a plus or minus solution. So again, this is I could write this a factor out in negative. That's gonna be negative root 5 plus I. Yeah, enter it up.
Yeah.
Isn't that just the negative version of this?
Yeah.
Yes. Anytime you find your root, it's gonna be you're always gonna get a plus or minus solution. So I could write the general solution for z as plus or minus root 5 plus I. Because plus of
Yeah.
that would just be this, and negative of that would just be this.
I understand.
Yeah. Right?
I
So
was watching a video and they did it like that, but I didn't understand it, but I understand it now.
nice.
So I get scared. Yes, when you put up that sticker, I clicked my screen at the exact same time. I was like, what do I do?
That's crazy, dog. That's crazy. That's crazy.
Oh my God.
Hmm. Which one is this? Scroll on screen quiet. This is perfect one. All right, so let's move on, right?
Why
Question.
would they look at me? Like,
That's a question 4. Solve for z in z squared minus 5 plus iz plus 8 plus I is equal to 0. Okay. Right, so for this one, you had to use the quadratic equation, right? Straight did you know that?
Yes. Yes.
So tell me what a, b, and c is one time.
A is 1, B is minus 5 minus I, and C is 8 plus I.
A is Juan. Juan.
Juan.
Right?
Uno.
Right, minus 5 plus I, and c is equal to. So everybody okay with this, right?
Here.
yeah.
All right. So to find for z, that's going to be negative b plus or minus square root of b squared minus 4ac all over 2a right? So that's going to be negative negative 5 plus I is just 5 plus I. Are you confused?
Mm-mm.
No.
Okay. Again, a whole little high standard, right? And it's pretty, I do detail working, but some of the stuff I see, I think now they could see, I just kind of skip it to save time,
Yeah. Yeah.
right? Then you're going to get b squared. Now, b squared is going to be open bracket minus 5 plus I close bracket all squared. Yeah,
Mhm.
Mhm.
right? Minus 4. A is 1 and C is 8 plus I all over 2 by 1 is 2. Right, so you're going to put 5 plus I plus or minus. And I want you to understand that that negative by 5 plus I, it could mean the exact same thing as negative 1. Negative 1 squared is just 1. So we're really looking at 5 plus I. Yeah?
Yeah.
Straight up, I'm going to run through that one more time. So we have negative 5 plus I squared. And
Mhm.
that means the same thing as negative 1 by 5 plus I squared. And wouldn't that mean minus 1 squared by 5 plus I squared?
Mhm.
So isn't that, aren't I just interested in finding 5 plus I squared?
Yeah.
Right? So 5 plus I squared. Let's do that real quick. So 5 plus I by 5 plus I. That's going to be equal to 25 plus 10I minus 1. You understand how I get out?
Yep. Yep. Yep.
Right, so I'm going to write that over here. Going to write 25 plus 10I minus 1. And over here, I'm going to write, so that's going to be minus 4 by 8, which is minus 32. Then minus 4 by positive I, it's going to be minus 4I. I lose anybody yet?
Mm-mm.
No.
All over 2. So that's going to be z is equal to 5 plus I plus or minus the square roots.
Mhm.
Real parts over there is 25 minus 32 minus 1. So that's going to be minus 33 plus 25. Straight out, what's minus 33 plus 25?
Minus 33.
Plus 25.
You mean 32?
Now watch.
Oh, oh, sorry.
Yeah,
Minus 8.
right? It's going to be minus 8, right? And what is 10I minus 4I?
Plus 6i.
Right? Emma, you got that right? So far good?
Yeah, yeah, I got that.
Okay, good. So straight, I understand why I call this a deadly question.
Yeah. Yeah. But yeah. So far again, true.
But then this
Uh-uh.
is where, they would say, who pits the fan?
What? What? What?
People would be like, well, the shit hits the fan.
Oh.
Yeah.
I just didn't want to say shit.
So you're fine. Relax.
All right.
It's okay.
All right. So the reason why I call it a deadly question is you had to you had to find the square root of minus 8 plus 6I. Right? So come like it's come like two questions.
Mm-hmm.
So finding the square root. Wait. Mhm.
I don't know how I do my work. It's so confusing. Like it's I follow my working while I'm doing it, but then when I look at it, I have no idea where my brain was going.
What? I go check your work and don't worry. By the
Oh
way,
no, you check it already. So I don't know how you follow.
this one was fine. Yeah. I think, bro, I just checked to see your final answer, no. I like be working along the way and I find it makes sense. So I didn't check like everything like extremely detail because like I think I was teaching, yeah, before you all had the advanced class.
Oh
So
my
I
God.
check it out. I check it through, but not like 100%. It looks correct, right? All right. So we have to find the square root of minus 8 plus 6i, right? And that would be equal to x plus yi. Should be familiar with it by now,
Yup.
right? You square both sides, it's going to turn to minus 8 plus 6i, which is going to be x squared plus 2xyi minus what trait, huh?
Y squared.
Right. Oh, Emma, before class finish today, I'm going to do work on the Argand diagram, and I'm gonna go through the Morse theorem for you. Just quickly, so you go understand the concept behind it, right?
Yeah.
Yeah. They're gonna be mind blown. They're gonna be like, what?
Bumbo class.
Right? We had to do complex and um first semester year one in electrical engineering, and it was so fun. I was like so I was key.
Well, I was gonna ask, I was gonna ask you, right? Every evening you have classes?
No, just Tuesdays and Fridays. Like I have two classes back.
Oh, okay, okay.
Yeah.
Because I was like, I'm wondering if you have lessons every evening, how you gain like enough time for you and your self-revision with UE.
It's a valid question. Most of my class, all my classes finish 8 o'clock in the night. Eight or
Right.
so like I don't know. I don't know. And the classes start 8 o'clock in the morning. Stuff,
Haha.
stuff. But at least I have no school. So
What?
that's good. So
I
okay.
didn't hear what you say just now.
I say classes start from 8 o'clock in the morning and it's like I reach from 8 o'clock in the night. But the only good news is I don't
Yeah.
class on Tuesdays and Fridays.
Okay.
Okay.
Yeah. All right, so let me continue. So again, I'm going to use different colors so as to not discriminate. Oh, or you don't get offended by my statements, something, right? I mean, I don't really know what
Ah,
you're offended about.
be so
Calm
for
down.
real.
I don't know.
You're talking to us to inform for. We,
Exactly.
if it bothered us, we would have left so long ago.
All right, I'll continue. I will tell you something when I finish class, right? Just remind me to tell you, right? It's a piece of bacana. No, a piece of
Oh,
or something funny.
tea.
Funny.
Do
Some
I sense tea?
just remind me to tell it after class when you're recording on there, right?
Okay, 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 fine.
So the real part, right? And the real part would be loneliness and the depression. And the imaginary part would be happiness.
I
Mhm.
like that. Yeah, you explain it just like Miss Nagita. Like she explains everything just like Sid does.
Oh, yeah. So the real part, big up Miss Sangita one time. Right, so the real part gonna be so minus 8 it's gonna be equal to x squared minus y squared, and the imaginary part, wait, I'm gonna write a funny note on it. I could like post it up on top. So like wait, a real part, loneliness,
Mm.
lack of sleep,
Mm.
Yeah.
and depression.
Mm.
We'll come back in 1 minute.
All right, and the imaginary part, happiness. I hope I spell happiness correct.
HAPPINE. I don't know, so I kind of dyslexic.
That would happiness. Um, well, sorry.
No school. No school.
What do you mean? Imaginary part, like you want. Okay, well, for no school, school, love.
Love.
Oh, yeah. Wait there. At math vibes.
Wait, take the screenshot of the picture now, or
Yeah.
also you want to take it because you have the aesthetic setup. I don't have no aesthetic setup.
All right, all right. You're lucky at home and not by my aunt. Otherwise, I would not have the aesthetic setup.
Oh, okay, okay, okay.
I have it though. One momento. Trying to take a good picture.
Wait, before I take the picture, you want to write out the imaginary part so we confuse the people who don't know about pure
Yeah, yeah,
maths
yeah.
a little more.
Let me do that.
Mhm, mhm.
How we call it in too, right? So imaginary part is going to be 6 is equal to 2xy. Yeah, right? And I call this equation 1. I call this equation 2, right? And you're gonna make equation 3. Let me like fill up the screen with madness. That'll be fun, right? So you take the equation, we want to make the subject x or y.
Why?
Y.
Yeah, why?
Right? So y, which is red. So y would be equal to 6. 6 over 2, it's gonna be 1 over 3. So I'm just gonna write 1 over 3x. Yeah?
Wait, what are you doing? Isn't it 3 over
Um,
X?
yeah, I think it's supposed to be 3 of
Yeah,
X.
but you know, boy, like
His eyes, his eyes.
looking at me right now, you know. My grandma's on looking at me. Yeah.
So the kind of mistakes Mr. Rambert used to make sometimes. And he should just be like, he just make that mistake. He making sure we paying
Paying
attention.
attention.
Well, I gotta start doing that now. One one of our lecturers, I should see him. He's so funny. Like he real funny. Like he just make mistakes on purpose because he tells us that from his experience, people cast for their own mistakes, but when they see other people making mistakes, there's how I feel they
Isn't that something Einstein said?
was that
Like, he said something, he did like a whole equation and he like put 91 instead of 90 or something, and people commented about that and not all the progress he had made before. I guess it's supposed to be like metaphoric.
like success was like built on mistakes.
I like no matter how well you do, if you make one mistake, somebody will notice and point it
Yeah.
out.
Yeah, yeah, yeah. That's true. That's true. And it's kind of like this. I just have this like animation like with this big giant pulling up a rock from like um crushing like a village,
Yes. Yes.
and it's like one small rubble happen and they just have to stone him down. Boy, people like this
He let the whole boulder fall down on them.
real valid crush. That's the day one valid.
Yeah.
That's the day one valid crush shots.
Yeah.
Take a nice picture of this. That one. Nice. I'm send it to you real quick. What is love? Baby, don't hurt me no more. Uh,
You can find that song.
eh?
Yeah, I not think we could use that song.
What is love? It's imaginary. It ain't real.
Nah, but if you post that and your girlfriend gets upset.
I will tell she the real part makes more sense. Because if she get vexed, I will be lonely, be depressed. And I'll stay up because I'm depressed and I'll be like asleep.
Mhm.
But I don't know how to reply to these things. All right.
Reply to what?
Reply to like, okay, you just tell me what I'm gonna do if she see me, like she serious. I tell you, but I'm gonna be lonely, I'm gonna be depressed, and because I'm depressed, I'm gonna lack sleep. You see like our time and everything there?
Yeah,
Yeah.
yeah.
All right, so let me continue. Let me speed up, right? So I'm gonna just anywhere I see y, I'm just gonna put 3 over x. So I'm gonna end up with n is equal to x squared, right? We're gonna end up with minus. Okay, what? I'm gonna speed up a little bit, right? You're gonna multiply 3 by x squared. We know that. If you do that, and you move across everything one time, you're going to get 0 is equal to x to the power 4 plus 8x squared minus 9. Are they understand or are they confused?
I understand.
Yeah.
All right. So if I have,
With um no, this is fine. Sorry, continue.
okay. And then we could say let x squared be equal to t, right? Okay. You know why I'm using t?
Because it's already C.
Now, because my notes are t. All right.
Body T.
All right.
Body T.
Body is T.
So you're going to get t squared plus t minus 9. I feel like all of this pyramids be a gilded, you know. I feel
Mm.
I feel sure gonna be a guild child, honestly. I can't imagine it being a boy child. I don't know. All right. And I'll be equal to 0. To get t squared, I'm gonna be t by t. To get plus 8, you would say minus 1, and you would say plus 9. Okay, understand?
Yeah.
Yeah.
Right? So t would be equal to 1, and t would be equal to minus 9. Oh. The one that actually find the square root for. I mean, 1 is fine, right? You can find the square root of 1, it's just 1. But like 9, 3 plus or minus 3, but our dreams have been crushed. It's a negative number. Can't use that.
Yeah.
So x squared is equal to 1. So x would be equal to plus or minus 1. This question is so long. Right?
Exactly. I took so long to do these questions.
Wait till
I was like, why am I? Huh?
wait till I had to do like second order non-homogeneous differential equations. Oh God.
Okay.
All right. So let me figure this thing out real quick.
I think I cannot also say the name of that.
Say that again.
I say already taken an hour to say the name of the differentiation.
Yeah. Yeah. Already end. Right? So guys, remember how I told you all that when you find the square root of a complex number, the solution will always exist as a plus or minus in a plus or minus form.
Yeah.
Yeah.
So check this, right? Um, the answer is going to be right. So the answer is going to be so the square root to answer
Mm-hmm.
copy this. The answer for that is gonna be it's gonna be a plus or minus solution, right? So it's going to be equal to plus or minus 1, right? Let me show you what I mean, right? So if I take x is equal to 1 and I plug it into y, what am I going to get?
That is why.
When x is equal to 1, right?
Y is 3.
I was 3 over x, right? So y would be equal to 3 over 1, which is 3. So in that case, the answer is going to be plus or minus 1
1.
plus 3i, yeah? And if you were to use the other one, which is negative 1, you would get y is equal to negative 3. So I understand that Okay, the first one is 1 plus 3i, and the second one is minus 1 minus 3i. If I were to factor out the negatives here, I would get 1 plus 3i. So that's why I was saying that the solution is just plus or minus 1 plus 3i. All understand?
Yeah.
They're sure.
Yeah.
Mm-hmm.
All right, so straight are you good, right?
Yep.
Right, x is equal to minus 1. All right, so this is the general solution. So we could recall what the original thing was. So recall that, this was the case, right? Trying to make it
Uh,
fancy. Right? And so we could go ahead and solve it now. We good. So oof. So z would be equal to 5 plus I. And let me look at the positive one first. So the positive one go be 1 plus 3i. What's in plus or minus? This be plus 1 plus 3i all over 2. Just to be safe, I'm going to put it in brackets. It don't matter, right? Because it's plus, right? But I just put it anyways. Right? So, Shweta, if I simplify that and I add the real parts, what I end up with?
With that one, 4 plus I.
No, that'll be 6. That's going to be 6 plus, is that 6?
Oh my gosh. Oh my gosh.
Oh my
Oh
God.
my God.
God damn. Right? That's be 3 plus 2i. Right?
Am I actually, what was I thinking when I wrote this?
Me too.
And then other one,
What?
other one, it's gonna be 5 plus I minus 1 plus 3i all over 2. So z is going
I
to be
don't know.
5 plus I minus 1 minus 3i. Unless you were somebody this root, which is, yeah,
No.
that now 5 minus 1 is 4, right? And I minus 3i is minus 2i over 2. So z would be equal to 2 minus 1i, which is just I. Everybody understands? So this could be,
Yeah.
and this could be z2.
Imagine I do everything else correct. Back on add and subtract for the last part.
That's that's crazy, bro. Wow.
Mm-hmm.
I don't
But
know.
sometimes if you even get a mark for the answer, you could probably get the whole question correct.
I don't know going on which fate on this minus and boy.
No, sir.
What we
Wait.
what we know with you on this minus and boy.
I don't know. Mm.
Right, so that's it. Mm-hmm. Yeah,
Oh,
that's
the fight so long.
but the notes aesthetic at least is looking nice, looking very sleek.
Yes.
Right. So let me move on to question 5. Question 5 is another interesting one. Let me speed run this. So Shweta, let me try to not talk ship on this. Are we lucky and just finish this fast? So
Yes.
the part E. What is love? That's a
So what happened to not talking shit on us?
that's a emote fast,
So
right? Find complex numbers. U is equal to x plus yi, such that x and y are real numbers, and u squared is equal to minus 15 plus 8i. Okay, they want me to find the u, right? Wouldn't u just be the square root of u squared?
yep.
Yeah. Right, so u squared is equal to minus 15 plus 8i. Right, so they want us to find for u. U would be given by the square root of u squared, which would be equal to the square root of minus 15 plus 8i. So this is what u is. Right? And so we're going to say that the square root of minus 15 plus 8i. Like after today, like all I had to get, boy, all I had to get these complex number questions correct. Eh? Bro, come on. All I have to. After today, like,
Period.
yeah, because we went through some tough ones, right?
It
So
don't get harder than this.
it kind of,
No, not
No,
really.
I mean like for just like for what we know so far with this.
oh yeah, it really get hard. Like we went through some tough ones and all that. Yeah. If we square the other side, that other side going into x squared plus 2xyi minus y squared. The real parts is going to be x squared minus y squared is equal to minus 15. And the imaginary part is going to be 8 is equal to 2xy. If you divide through by 2, you're going to get 4 is equal to xy. Right, so we have 1 here. We have 2 over here. We're going to use equation 2 to make equation 3. So we're going to say equation 3 is y is equal to 4 over x. Are you okay with everything I'm doing so far?
Yeah.
Yeah.
All right, you're going to plug that into equation 1. Before I do that, let me just make a note here. So this is the real part, a real bad man. It's the real part. I'm just funny, you know what I mean?
Yeah.
Yeah.
32, babe. I wonder if that was the actual number. What was the actual number?
What?
You know, like, and we talking about the same Jamaican guy that was like, that was talking about baby mothers and, are we talking about difference?
Okay, now probably just hear the audio real bad now. Or if
Yeah.
I didn't see it. And
I was sure, right? So we're going to plug 3 into 1. And so that's going to be x squared minus 4 over x squared. And I'm going to move across our minus 15 one time, right? So x squared minus 16 over x squared plus 15, I should multiply throughout by x squared. If I do that, I'm going to end up with x to the power 4, right? Plus 15x squared minus 16 is equal to 0. I'm going to say let x squared be equal to t. All right, once you do part A correct, B really easy. All right, so you're going to end up with t squared plus 15t minus 16 is equal to 0. Factorize this. T squared is t by t. To get 16, I could say 1 by 16. And to get back plus 15, I would say plus 16 minus 1. So t will be equal to 1. And again, our dreams have been crushed because t is equal to negative 16. Right? We can't use this one. So
Yeah.
x squared is equal to 1. Something I didn't realize, right? Like the notes for pure maths, like real long, like real long. Like, wow. I think I had like
mm-hmm.
3 long textbooks. Like it was insane. Right, so x squared is equal to 1. So as always, x could be equal to plus or minus 1, right? So if x is equal to plus or minus 1, let's consider the positive first. So when x is equal to 1, right? Y will be equal to 4, right? So y will be equal to 4 over 1. So y is equal to 4, right? And when x is equal to minus 1, y will be equal to negative 4. So back again, I was saying about the plus or minus, right? So therefore, right? Right. Notice it said find the complex numbers, eh? Complex numbers, not just one, two. So your answers it would be, right? So u will be equal to x plus yi, so that's going to be 1 plus 4i, right? And the other answer for u will also be equal to minus 1 minus 4i. And it could also wrap up by saying u is essentially equal to plus or minus 1 plus 4i. Everybody okay with this question?
Yeah.
Emma, you got this?
Yeah.
You see that kind of show how I would trust you.
Oh no, I just saw 1 plus 4, so I just wanted to look at moderates. Yeah, I got that.
Okay, cool. Um, Shrita, you did the questions, right? Yeah, I mean you did. I just didn't get a chance to see
Yeah. Had I forgot that wrong, I got two wrong, and three I ended up making a mistake and I get that wrong. Four, it was just a little ending up piece. I couldn't add and subtract, but other than that, yeah. Again, it correct so far.
all right. Right. Okay, so let's move on, right? So B. Yeah. All right. Hence or otherwise, solve for z in the equation z squared minus 3 plus 2iz plus 5 plus I is equal to 0. So we gotta use the quadratic equation again, right? You know how the badnesses go. A is equal to 1, B is equal to 3 plus 2i. And more than likely, inside the square root sign, you're gonna see minus 5 plus 89, I bet. I bet they're gonna have that, right? So you wouldn't have to find the square root again, like the last question. All right, so Shweta, the formula for z is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so tell me what's a substitute, Shweta? That's going to be minus, I'm going to turn to minus what?
Wait, what?
You had to use the quadratic equation for this question.
Wait, so I think you make a mistake with
Yeah,
B.
yeah, b is supposed to be minus
Mm-hmm.
3 plus 2i, right? Yeah.
It's okay, it's in the night. We tired.
I need, yeah, I need some gyro.
Gyro.
Yeah,
Lamb gyro.
yeah, love that.
B.
Right, so
Okay, so
it's going to
it
be,
would it would all turn to positive, but
right, 3 plus 2i,
yeah,
right? Plus or
plus or
minus,
minus.
bro, what? Just do that line. Okay, cool. Hmm. Right? B squared, we already know how that's going to be. That's going to be 3 plus 2i squared, right?
Mm-hmm.
So I could just write 3 plus 2i squared. Because we know the negative when you square it. You know, like,
Yeah, it would poof.
yeah. 4a, a is 1, c is 5 plus I, all over 2 by 1, which is just 2. So z is equal to 3 plus 2i. What was that?
Sorry, that was me. I'm talking to Miss Rika. Oh,
You talking to what?
my teacher from Parvati that in convent with me now. I sent her the maths we doing, and she was like, Emma, we're friends. Let's keep it that way now. Send me more maths, and I'm putting you in enemy territory.
You're being the ops. And so 3 plus 2i squared, if I square that, that's going to be 9, right? 9 plus 12i minus 4. Yeah, straight up. You got that?
Yes.
Right? Then I'm gonna
Yes, 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 yes.
minus 20 minus 4i all over 2. If we simplify inside the brackets, what will we get?
I got minus 15 plus 8i.
Let me see. So 9 minus 20. Okay, so we have minus 24. Minus 24 plus 9 is minus 15. Then we have 12i minus 4i is plus 8i. And we already found the square root of that already.
Yup, that was really nice.
Thank God.
Mm-hmm.
So z would be 3 plus 2i plus or minus. We already discovered that. That is plus or minus 1 plus 4i all over 2. So let's look at the positive case. Right? So z will be equal to 3 plus 2i plus 1 plus 4i all over 2. That's going to be 4 plus 6i all over 2, which is just going to be 2 plus 3i, right? Then in negative case, z will be equal to 3 plus 2i minus 1 plus 4i all over 2. So z will be equal to 3 plus 2i minus 1 minus 4i all over 2. That's going to be 2 minus 2i all over 2. So that's going to turn to 1 minus 1i, which is 1 minus i. Guys understand this?
Yep. Yeah, I got that.
Okay, nice. So I could call it,
This was of the deadly questions, but the regular easy question. 2 and 3
well,
are
2,
very wrong. Huh.
well, it should not be a deadly question. Right? 2 was kind of hard.
Huh.
Yeah, 2 was kind of hard. Not gonna lie. Right? Cool. So let me move on to Argand diagrams one time. Right? I'll finish at 9, 10. Just want to show you guys what our Argand diagram is, right? Yeah.
Yay.
Mhm. Have you ever wonder why a negative number by a negative number is a positive number?
Yeah.
Serious? I'm sure. So let me draw a number line again, right? So call it 0, 1, 2, 3, 4. I want to think of multiplying negative as a rotation of 180, right? So if I multiply 1 by minus 1, that means I'm gonna rotate 180 degrees, right? Right? And if so anytime I multiply something by minus 1, that means I rotate in 180 degrees, right? So look with me so far, and if I'm
Yeah.
1 by negative 1, I'm gonna turn to negative 1, right? If I multiply negative 1 by negative 1, I'm gonna do 180 degrees rotation again. Where am I gonna end up back at?
1.
1.
Yeah. And like I said, if you want to go in the middle, so and we understand that multiplying by negative number is a rotation of 180 degrees.
Uh-huh.
But what happens in the middle? Right? Let me just say I wanted to that this angle looking like 45. Or what would that be? What would that be? That's where the imaginary axis comes into play and allows me to plot a point in the middle. Are you understand?
Mm-hmm.
You draw straight up.
Uh-huh. Yeah.
So the angle is always measured with reference to the real axis, right? So straight up, let me run that back one more time. So all angles are measured with reference to the real axis. So what's the angle, right? What's the angle from the real axis to the complex number? I feel like some people confuse. I feel like
You want the value or you want to like
wait, I'm gonna do this from scratch. Run this through from scratch.
no sir, understand, don't worry. Am you confused or am am
M&M with the Emma whole sign.
Emmanuel Flemmer?
Hmm?
Oh my God, where were you?
What?
Where were you?
No, internet bad.
Oh, okay, okay. Oh shit. She dropped.
All right. Yeah, so Emma, you understand that?
She dropped.
Oh, I see. Well, you understand that the imaginary axis allows us to move. Like, okay, before we could adjust do our rotation at 180 degrees, right? And that would
Yeah,
give
yeah, yeah.
that carry us a negative number. What happens if you wanna like get an angle less than 180 or more than 180?
Or just stop anywhere, yeah.
Just stop anywhere. That's where the imaginary axis comes into play, right? So
Mm-hmm.
again, the angle is always measured with reference to the real axis in a anti-clockwise direction, right? You see that? She joined and immediately, yeah.
She joined on.
She joined and then immediately gone, like flash.
She internet horrible.
I see that. Yeah. All right. So you understand everything I'm saying here, right?
Yeah.
So angle is always measured with reference to axis in an anti right. So you understand that? And you understand how we plot any points, right? So this point over here would be a complex number of 3 plus 2i. Tom, if you're okay with that.
Yep.
All right. Now, there are a couple of things we could do to state the properties of that complex number. So this complex number would have an angle, right? It would have a real dimension and an imaginary dimension. So the length here would the quote unquote length to be 3, and the quote unquote length for this would be 2.
Mm-hmm.
Right. If I wanted to find the magnitude or length of, I want to say vector, right? It's essentially a vector. I would have to use Pythagoras theorem and not.
Mm-hmm.
Okay. Say with me so far.
Yep.
All right. So you see that we call that R. So if I want to find for R, then I would have to find for the length of the hypotenuse. So R is just quite simply the square root of the real component squared plus the y component squared. Understand?
Yes.
So we could just say x squared plus y squared.
I'm back.
Who's back? Guess who's back? Guess who's back? Da-na-na.
Guess who's back? Back again.
It's like, if somebody wants to see some shitty. Yeah, I got. All right.
Don't worry, I understand this.
Like, real good, right?
Yeah.
Okay, good. So if you want to find, so straight up. Now, if you are plotting a a point on the Argand diagram, that's what you call it, you would see that there's an angle and there's a length for the complex number, right? So you could find this using Pythagoras theorem. Let's just see why, because it forms a
Yeah.
right triangle, right?
Mm-hmm.
And Pythagoras theorem says that the hypotenuse squared is equal to the sum of the other two sides squared. And so h would just be equal to 2 squared plus 3 squared square root of that, because h squared, to find the h, you have to find the square root. Yeah?
Yeah.
Right, so R, also known as the modulus of the complex number, is given by Pythagoras theorem. Cool. So in this case, if you wanted to find the length of this, how would we find that? Tell me straight, how would you find that?
The length of
The length of the length of this. And
the hype, just
you
the hypotenuse.
right. And you can call it a vector if you wanted. This could be point P, right? Then how would I find the length of O to P? How do I find that?
O to P. O is okay, it'll be h squared minus e.
Wait, I feel like you're overthinking it, and I feel like I'm making this one more complicated than it is. And this is a right angle triangle,
Mm-hmm.
and we have this length and this length.
Uh-huh. Okay, right, we didn't define it there already.
So in that case, h squared will be equal to 2 squared plus 3 squared. And to find for h would just be the square root of 2 squared plus 3 squared.
Mm-hmm.
Yeah.
Right. So straight up, generally speaking, if you want to find the magnitude of a vector, all you would have to do is just use Pythagoras theorem. So if you want to find distance from the origin to the point, you would just use Pythagoras theorem. And the general formula for that is the square root of the x component squared plus the square of the y component squared. That's just what I was saying. So straight up, listen to what I'm saying, right? I'm saying that if I want to find this distance, it'll just be the square root of x squared plus y squared from Pythagoras.
Right. Mm-hmm.
And so this is the formula we just use, which comes from Pythagoras theorem.
Mm-hmm.
Because, and you understand, if I wanted to find for h, I would say h squared is equal to 2 squared plus 3 squared.
Yep.
Then I would just find the square root to find for h.
Yep.
And I could just say I find the square root of x squared plus y squared.
Yep.
Right, so this is the general formula here. Right? If you want to find for r, which is the length from O to the complex number, you would just simply use our formula, again, which comes from Pythagoras theorem. So that would be the square root of 3 squared plus 2 squared. And what that'll be equal to? So that'll be 9 plus 4. 9 plus 4 is?
13.
Right? So in other words, this would be 13 units long. Square root of 13 units long, or 13 units long. Understand?
Yeah.
Yeah.
So that's one aspect of it. Now, Shweta, the other aspect you probably see is there's an angle involved, right? And you see that there's an angle involved.
You mean like they give you the angle and
You have to find the angle.
okay, right. Mm-hmm. So got the wall.
In the diagram, right? And you know what this length is and this length?
Yeah.
Right. So this is the hypotenuse. Since this is the side next to the angle, this is the adjacent, and well, this is the opposite. Right? Say what, no?
Yeah.
Right. If I want to find for the angle, look at the two sides I have.
1A.
I have O1 here. So which trigger ratio I think I should use?
Tan.
I should use tan, right?
Yeah.
Right. Emma, you agree?
Yeah.
Right. So if I wanted to find for that angle, right, theta would be given by, would be given by what?
Tan
Inverse
inverse
of two
of
of three.
Right? So in this case, theta would be equal to tan inverse of, because tan is over here, right? So that would be
yeah.
I over the x. Now this is not always the case, eh? In the next class, I will go into this in more depth. So theta is equal to tan inverse y over x. So straight I understand for this particular diagram and how it is right now, I wanted to find the angle between the real axis and the complex number. I would just find tan inverse of O, which is y value, and x, which is the a value. Yeah?
Yeah.
Right. So that'll be, so the y value here is 2, and the x value is 3. What's tan inverse of 2 to this?
But you
Degrees or radians?
calculated?
I don't like
Yeah.
know this off the top of your head, eh?
Oh, sorry, sir.
I don't know this myself. What happened? Yeah, what's tan inverse of 2 to this?
We do it in radians or degrees.
Give me it in degrees for now. Is typically in radians, but just to visualize it, give me it in degrees.
33.7.
Again,
What?
you get to the 3.69?
Yeah.
Okay, cool.
Wait, how am I supposed to know that off the top of my head?
You're not, you're supposed to use a calculator.
What?
I don't, I don't know that. So I can't figure that out. Right? So like these are the main things about you need to know for when you're plotting a complex number. Anytime you're plotting a complex number on the Argand diagram, you need to know its distance from the origin to the point, and you need to know the angle it forms with respect to the real axis. So these are the main things you need to know. Everybody okay?
Mm-hmm.
All right. Shweta, I mean Emma, you're probably wondering where this cool sign and this sign thing come from, it? Like where that come from?
Yeah.
All right. Okay. So Emma, nth the thing you would have probably you would have see that z is equal to r cos theta plus I sine theta. And that's what you would have see.
Yeah.
And you didn't really understand it so much.
Yeah.
All right, so I'm gonna blow your mind here. Pew. It all stems from this simple looking diagram. Check.
Oh,
So if I start to lose, you just tell me, right?
yeah.
Okay. So for Emma, so Emma, right? If you look at this diagram, wouldn't this correspond to the length on the imaginary axis?
Yeah.
So you with me for that, right?
Mm-hmm.
Okay, cool. You sure?
Mm-hmm.
All right. So let's see how you would find for that side. So if I wanted to use the trig ratios to find the length of this side, how would I do that?
Like opposite of a hypotenuse. Like that?
Wait, wait. It's supposed to have a way to do it. Wait, that I remember discovering. So if I do this, right? This will be 90. This will be that. So this is H. This is A. Right, and this is O. Hmm. Come on a second. All right. Cool. I have it. So Emma, check this, right? If I wanted to find for this length using the trig ratios, You would know?
Yeah.
Is you're supposed to have h, right? And if that is the case, and I could find for this component using sine,
Yeah.
right? So sine theta is equal to over h, right? And this would correspond to the imaginary part,
Yeah.
right? And where does cos come into this? If you want to find
When you find the real part.
right, when you find out for the real part, right? So why am I saying that? Well, it's supposed to know what the hypotenuse is and the adjacent.
Mm-hmm.
And so if that is the case, you can use cos to find that out. Tell me if you're confused.
No, I'm good.
Okay, so you could say, so cos theta would be a over h. All right. So this is the part where it gets interesting. So if I wanted to, so Emma, if you're looking at this, right, and you wanted to find for O, wouldn't you have to make O the subject of the formula?
Yeah.
So wouldn't O be equal to I sine theta by h?
Yeah.
Okay, stay with me. And if you wanted to find for A, which is the part on the real axis, what I'll be equal to,
H cos theta.
right? And remind me what was h?
What?
If I wanted to find for h, how would I find for h?
Using tan theta.
No.
Wait.
How would I find
Oh,
how would I find for h? How would I find for this length? Wouldn't I use Pythagoras theorem?
yeah.
And didn't I call her r?
Yeah.
So anyway, it's the h, I could write what instead?
R.
Yeah, right? And remember, a complex number is given by x plus yi, right?
Yeah.
X is the real part. So this is the real part. So I can write out as r cos theta, and this is the imaginary part. So I can
Mm-hmm.
write that as I sine theta by r. And that's how they come up with that over there. That's how they come up with it.
I understand.
Let me run that back one more time. So there's another way you can express a complex number using the trig ratios, right? And that form is z is equal to r, right? R what? Remember? Should I remember?
Um, um, Sine theta?
Am I she correct?
Um, what do you mean? You mean the same thing we had before? R by cos theta plus I sine theta.
Yeah.
Uh, yeah, there we go.
Right. So let me show you how they come up with this, right? So the R should be on the outside. Yeah. So I'm gonna show you all one more time how they come up with this. So Emma, do you understand that A, this A over here, wouldn't that correspond to the real part?
Mm-hmm.
Mhm.
Later, this O, wouldn't this correspond to the length on the imaginary axis,
Yep.
right? So you're sure. So so O would correspond to a 2, which is the complex part, and the 3 would correspond to the real part. Say what me so far, right, Shweta?
Yeah.
And so, okay, so O corresponds to the imaginary part, and A corresponds to the real part.
Mhm.
Am I confusing you?
No.
Okay. So we are going to find for everything using H. So straight up, if I wanted to find for the imaginary side and I have to use H as one of my sides, which trig ratio am I going to use? So if I
Sine.
had to use sine, right? So
Mm-hmm.
I'm going to say sine theta is equal to O over H. Now I want to find what my imaginary length is. So my imaginary length is given by what? OH. Check it out. Look
Your
at it.
imaginary length is given by
We have H O and A.
Oh,
All right. So you have to make O the subject of the formula. How do I make O the subject of the formula?
cross multiply.
Right? So, okay, so O would just be equal to H sine theta, hence.
Mm-hmm.
Right. Now, wouldn't this correspond to the imaginary part?
Mm-hmm.
So I write I. Did I confuse you?
Mm-mm.
Yeah, sure.
Yeah.
Right. Emma, are you confused or you're with me so far?
no, good.
All right. Cool. So straight up, again, we're using H. We had to use H, right? If I want to figure out which trig ratio I'm using to represent the real part, I would have to use H and I would have to use OA,
But the real
real
should
part.
be A.
I had to use A, right? So which trig ratio have A and H in it?
Cos.
All right, so I'm going to say cos theta is equal to A over H. Right. I want to find for the real part, which will be given by A, yeah?
Yeah.
Mm-hmm.
Right. So I would cross multiply, and so A would be equal to H cos theta. Are you confused?
No,
No.
Shweta, be honest, are you confused?
no, I understand.
Right. And Shweta, enter complex number is given by its real parts.
And the imaginary part. Yeah, yeah.
By
Mm-hmm.
real parts plus the imaginary parts. So, what is the real part? What could I use to represent the real part? The A or the
You
O?
mean like, oh, the real part is E.
Yeah, check it out. The real part is given by A. If you look at the diagram, A is 3. That's the real part.
Cos is real.
Right? So I'm gonna write H cos theta, and the imaginary part is given by what?
Sine.
Right?
H sine I.
Right. Are you all seeing anything in common with these two?
They both
H.
have H.
Right, so we could pull out the H and we would
And
write
H is really Z.
nano
R.
R.
Oh,
No, but the, yeah.
Because and to get H, we said that H is basically the length, the length of the length
yeah.
point to the origin.
Yeah,
Uh,
I mixed up my letters.
and we had called that R, right? And R is just the magnitude of the complex number.
Okay.
So we could
You
replace,
could put a, you could just write that this side R is the magnitude of the complex number.
right?
Yeah.
Right. So R magnitude of the complex number from the origin right? From the origin to the point on the Argand diagram. Yeah, you're good. So that's,
Yes.
Yeah.
and theta is just the angle with reference to the real
This.
axis and the magnitude.
No, Miss says the line segment.
Yeah, you can see that, right?
I can leave the magnitude. I think the magnitude is easier to remember. Okay.
Line segment. It's really a vector. It's really a vector. Yeah,
Yeah.
it's really a vector because this could be a point for call C. So this vector will be O to C. Yeah. Right. So these are the main properties you need to know when you look at Argand diagram. So straight, I mean, Emma, do you understand the origins of it now?
Mm-hmm. I understand.
Nice.
So I
Now
have a question. What kind of iPad you have? I just have to pick.
I have a M2 iPad Pro.
Woo!
I remember the night I went to go buy this.
Yeah.
Yeah, and I was so excited. I went, boy, the drive I had to make to get this was crazy. But I get the Apple Pencil and I get the iPad for 4,000.
Wow.
And I get screen protector and I get a case. Two cases actually. So like
Take a puppy.
Well,
256 gigabytes as well.
oh, oh my God. Well, I like my iPad a lot, like the iPad itself. The only thing I don't like is that the pencil, I have to get a cord and an adapter to connect, like to charge my pencil.
Well, yeah. Oh, you have, yeah, that one kind of annoying. I wouldn't lie. Because like,
But
but at least you get to use it while it's charging. Does it work like that?
no.
Oh, well, never mind. I thought I could have make up.
It only takes 10 minutes to charge, it's fine.
Oh, well, never mind. Right?
It really isn't. I just if I'm running out of battery, I just charge it during recess time and it's like fully charged by then.
All right, cool. Cool. So, let me show you something, right? So, Eman Shweta, check this out. And the original complex number was z is equal to 3 plus 2i. Yeah,
Yeah.
watch this, right?
Yeah.
Show bad maths is. So like z. So I just showed you all how they came up with the trigonometric form, right? I showed you all how they came up with the trigonometric form. Let's see if it works. So we found r to be root 13, and the exact angle, like the actual angle, is tan inverse of 2 over 3. So I'm gonna plug in the exact things, and you're gonna see what's gonna happen, right? Right? Right. So let me do that. Plug it into my calculator, and you're gonna see magic. Just keep in mind the original one was 3 plus 2i, right? 3 plus 2i. Right. So root 13 cos tan inverse 2 over 3 plus I sine tan inverse 2 over 3. Right. I'll make sure I'm not forgetting any brackets. I would hate to do that. Okay, look, I forget one of I. Actually, yeah.
Um, I don't think so.
Yeah, I was. Bam, look at that. Have you seen it?
Yeah.
Shit, so do I get back to the original root? I mean, do I get back to the
Yeah.
complex number?
Mm-hmm. Yeah.
Yeah. Isn't that cool?
Very
Yeah.
Yeah.
puzzling.
Now, in the next class, I will show you the proof for the Morse theorem. Um, Show you how everything will work. Yeah. And I'll show you the principal argument of a complex number. So we would have find the principal argument. So like you see how we found theta to be 33.69? That's
Yeah.
the principal argument. The basically the angle in the first quadrant. I'll show you
Okay.
how to find angles in the other quadrant.
Yay!
Okay.
Right? So how to find complex numbers going so far? We good?
Yeah, we good.
It's good.
Are we Gucci?
Mm-hmm.
Nice.
Mm.
So I'm going to send these notes one time.
So don't forget your tea for me.
Oh yeah, yeah, I don't end the meeting for that.
Recording. And the recording, not the
Yeah, yeah, yeah.
meeting.
We're saying, boy. I just start to get tired, I don't know. I just start to get tired, boy.
Mm.
Say things.
Mm.
Because like I I don't know how I do that I don't know how I do that 24-hour marathon, you know. I don't know
Me
how
neither.
I feel tired after teaching for 4 hours, but I do that 24-hour marathon and I was fine after. And the 17-hour marathon I did, I felt fine after as well.
So I have a question. For that whole marathon, right? Like you took any break, like get up or like eat something.
Yeah, yeah.
Oh, okay. Just making sure.
That'd be crazy if I didn't.
Yes.
I go under a 72-hour marathon.
So bye.
I want to do a 72-hour marathon with like okay, first 24 hours maths, the second 24 hours physics, and the last 24 hours art maths.
You're not doing the same thing.
Say that again?
I said once you're not doing the same thing,
What do you mean doing the same thing?
like the same subject.
Ah, I want to like set an unprecedented record that like nobody would be crazy enough to challenge.
You might
I'll
get some
go for it.
recognition from Kerwin Springer.
Like he come on the video and he was like,
Yeah, I saw that.
yeah, but I don't think
That
he could
was
get through 72 hours. Telling this how to do is.
Teachers don't care. Like they like Terry and Cohen not helping us for keep.
Say that again?
I said Terry and Cohen not helping us for keep.
They're
but
not,
like
they're not helping for keep?
yeah, like you know how for CSEC it has so much of like CSEC videos, but
Yeah.
them it barely have any Cape videos. Barely.
The chemistry, I don't really have any videos, but it has a YouTube channel that Tracy and I look at called Arit Institute of Science, and they have physics and pure unit 1 and 2, and their teachers are all good.
Okay,
But
nice.
the only thing is a recorded class, like it's like a physical classroom and have children. You don't see the children, but is be from like a whiteboard. And sometimes there is lag.
And it's Cassie.
Sometimes yeah, on the board. As
Sometimes I
in
just don't bother and I just listen to what he's saying.
So let's say like I should do a live, like a 24-hour live or something for like keep.
bet we go join it. I go get my friends to join it.
I'll
Nice.
get my friends to join.
Nice.
Oh, I'll try.
Mm,
Well, I'm going to make history. I'll be the next great thing. The next great thing.
yep.
Yeah.
Yeah. Because I mean like the big dogs got like the previous gen big dogs got silly clever, you know what I mean? Like I
Mm,
mean
you get a little challenge.
yeah. I don't know if you see the quality of the animations on them, like my newest videos, like it's insane. Like I take weeks through some of them videos.
I saw the one with the logs on. That one was funny.
You watch the Matrix video?
I don't think I saw that one.
And you sure like that? I have real views on TikTok and thing like that went
Mm.
a little viral.
As-
I was sending.
Um,
I will. I was saying it real bad, real bad. Like I record a video of myself on my camera, like in the rain and all kind of things. Real funny. I was saying it. But that's it for class today. Next class, we're going to dive further into Argand diagrams and we're going to look at the different rules, the different diagrams you need to look at. That's gonna be quite long. Yeah, that's
Okay.
gonna be quite long. But
Oh, sorry, Shot, we need coffee for next class.
yeah, but I wouldn't say we that far from finishing, guys. I wouldn't say we that far from finishing.
No, it doesn't really have that much because it's just the way the Moivre's theorem thing, and then after it's just a little more on the Argand diagrams with circles.
Mm-hmm. And then after this, we're going to differentiation.
Uh,
Uh,
Yeah.
okay.
Oh, yeah. And so, yeah, guys, have a good night. Later, everybody.
bye.
The tea.
Back on the TT. Gonna stop the share.
Oh.
It's not that ground.